This is the third and final video for the Sine Law for Pre-Calc 11. So if you haven't already seen the first two videos for section 2.3, definitely go and check those out, or else you are going to be very, very lost for the next 20 to 30 minutes. So once you've got those and you've really got them settled in, this is the place you want to be. So in the last video, I went over how the fact that the sine law sometimes has more than one solution. And then I promised in this one I would go over how to actually get those. So that's what we're going to do. It's basically just going to be, well, how do you take all the information you're given in a question and figure out two completely separate triangles that match that information. So let's say we have angle A is 47 degrees, side A is 9 centimeters, and side B is 11 centimeters. And I want you to determine the length of side B. So what this question is basically like is, imagine if somebody said, hey, here's a couple of pieces of wood, use them to make a triangle. Depending on how those pieces of wood relate, there is definitely a possibility that you would be able to make more than one triangle, as long as you've got things set up in a specific way. And if I narrowed it down and I said, hey, make me a triangle, but use this specific angle, that's going to make it a little bit tighter. But there will still be some cases where you might be able to make two triangles out of it. So the first thing we need to do is decide how many solutions this thing is going to have. And so this is what we did in the last video. So we're going to determine the number of solutions. And so remember, we want to use our flowchart. I didn't mention it in the last video, but the flowchart was included in the description of that video, and it will also be included in the description of this one. So if you need the flowchart, make sure you check out the link down below and go over to the drive and pick that up. If it's not there, feel free to reach out and I can always send it to you. So looking at our flowchart and getting rid of the fluff that we used last time we did this, our angle A is acute. So we are going down the acute path. So the first thing we need to do is figure out what H is. So looking back over here, H is B times sine of A. So if B is 11, then we're doing 11 sine of 47. If you plug that into a calculator, you're going to end up with 8.04. So based off of this, let's go back to our flowchart. So we have figured out H. Now we're here. Is A bigger than B? Well, no. A is 9, B is 11. So we keep going. Is A smaller than H? Well, no. A is 9, H is 8. So 9 is bigger than that. Is A bigger than 8, or is A equal to H? No. We keep going. Is A in between H and B? It is. 9 is between 8.04 and 11. So we have ended up at two solutions, which you probably could have guessed since that's what this lesson's all about. So since A is in between H and B, we have two solutions. But that's not where we're stopping now. Now we actually want to figure out what those two solutions are. So we're going to figure out our first value of B just like normal. So first value of angle B, just using sine law, the same way we did in 2.3.1. I should also say now, before I forget, the fact that this has two solutions means there are two solutions for every single bit of this triangle that we don't already know. So angle A, or side A and side B, those are set in stone. We have one solution for each of them. There's no solution even, they're just given, so you know them. But the things we don't know, which are angle B, angle C, and side C, there are now going to be two possibilities for each of those. We're basically going to construct two completely separate triangles using the information that we have. And so depending on which triangle you're in, you're going to get different values for those three measurements. So our first triangle will probably look something like this, where we've got our 11, we've got our 9, and we know this angle over here is 47 degrees. And so if this is A, and this is B, and this is C, right? So this is just the same sort of setup we had in our notes from the last one. So right, this same setup we had here in sort of our basic construction. So if I want to get angle B, I'm just going to do sine law. So sine of angle A over A equals sine of angle B over B. We plug in some numbers. So we know angle A is 47 degrees. We know side A is 9. Angle B is what we're trying to find, so we'll just leave that as is, and side B is 11. So if we want to solve for sine B, remember you can either cross multiply or you can just isolate by multiplying both sides by 11. And so what we end up with is sine of B equals 11 sine 47 divided by 9. And so we're going to go through the same steps we did a couple of videos ago and do our inverse sine, sine negative 1 of 11 sine 47 divided by 9. And when you do that, you're going to get angle B is 63.36 degrees. And I know I normally do like whole numbers for angles, but since we're not done this question, this is just kind of a step along the way. I am going to leave it going a little bit further. And again, we don't really want to round at all. You don't round until you're done. So in this question, we're going to be done pretty soon, but there will be questions where you're going to use this number to help you calculate like 5 other things. And if you round right now, all of those 5 things are going to be kind of wrong. And so there we go. We got our first value for B. So let's actually go back and say, okay, these are all B1s, right? Angle B1. All of that is our first value. So now we want to find angle B2. And that is going to rely on something that we learned earlier in the chapter that I said we wouldn't need much of, but we did need a little bit here. So we get our second value for B. Where that's going to come from is it's going to be some other angle that's still going to make this equation true. And so since the 47 and the 9 and the 11 can't change, the only thing that's going to change is the B. That means that this thing has to be able to come up with some other number that's going to give us the exact same overall value for sine of B. So sine of 63, right, because 63 is the first value we got, is going to have to be the same as some other sine ratio. So if you think back to earlier in the chapter, there are some angles that share the same trig ratios. And that has something to do with reference angles. So the other value for B is going to be the angle specifically in quadrant 2. And I'll get to why in a sec. So the angle in quadrant 2 that has the same reference angle as B, which is just B. So it has a reference angle of our first value for B. And so the reason it has to be an angle in quadrant 2, well, there's 2 reasons to kind of justify that. First, if you had anything bigger than quadrant 2, you'd have an angle that's bigger than 180, and you can't have anything bigger than 180 in a triangle. It just doesn't make sense. But also we can think sort of ASTC stuff. We need it to be exactly the same, which means we need it to stay positive, right? In quadrant 1, it was positive. So we have to go to quadrant 2 so that we'll also get sort of a positive value out of this thing. So we're in quadrant 1 or we're in quadrant 2. That's it. And so what we're ending up with, basically, if we sketch this out really quick. So we had our first value for angle A, or for angle B, which was 63 degrees. So something like this. Our second value for B is going to be the angle in quadrant 2 that has that reference angle of 63 degrees. So this is the other angle that we're looking for. That's our B2. And so it's really easy to get. B2 is just going to be 180 minus your first value for B, your B1. So if you subtract those two things, 180 minus 63.36 is going to get you 116.34. And so that's it. We're actually done this question. So B1 was 63 degrees. B2 is 116 degrees. And so that triangle, if you're curious, would look something like this. So thinking back to that same drawing we had earlier, let me even just copy and paste this thing. So we've got the exact same starting information, but the difference being, if I change this side A and I make it point in a slightly different direction and had it pointing, say, this way instead, we'd have ended up with a triangle that would have looked like this, where this still would have been 9, but now things look slightly different. And so this is angle B down here. And so you can see angle B is now much bigger. And so those are kind of always going to be your two cases, where you're going to have a triangle that looks something like this, and then a triangle that looks something like this, where this is your first B, and your, well, sorry, this is your first B, and that's your second B. And so let's put a box around those, because that's our answer. We're done this one. Oh. And so, oh, hey, I made a small mistake with my writing down earlier. That shouldn't have been 116.34. That actually should have been 116.64. So let's fix that real quick. And then this should have rounded to 117. So sorry about that. I do make mistakes. All right, let's try another one. So this was just getting your second value for your angle. But what if you had to keep going? What if you had to get the other angles and side lengths? So if angle A was 30 degrees, side A was 24 centimeters, and side B was 42 centimeters, I want to know the length or lengths, right? So I'm not saying whether there's one or two, but you can probably assume there's two, of side C. Okay, so flowchart. We are on the acute side. If we do H equals B sine of A, that's going to be 42 sine of 30, which is going to get me 21. So if I plug that into my flowchart and follow it along, I will find out that I do end up with two solutions here, which you probably saw coming. So if I want to find the length of side C, so if we just sketch this out real quick, right? So we've got 30 degrees down here. We've got side A is 24. We've got side B is 42. So I want to find out this side length at the end of the day. But to get that with sine law, I'm going to need to know angle C, right? Because sine law, you need to have sort of those opposite pairs. And to get angle C, I'm going to have to know angle B. And so we need to find both options for angle B, then both options for angle C, and then finally both options for side C. So we're basically going to be calculating 6 different answers to finish this question. So to start that all off, we need to find our values for angle B. All right, it's really the only thing we can do with the information that we have. So we've got our sine law. Sine of A over A equals sine of B over B. We plug in everything we can. So we know angle A is 30, side A is 24, angle B is what we want, and side B is 42. We do some cross multiplying or isolating, we move things around. We're going to end up with sine of B, or specifically sine of B1, right? Our first value is 42 sine of 30 over 24. So to get our first value for angle B, we're going to do our inverse sine of that, which is going to get us 61 degrees. So based off of what we saw on the last one, our second value for B is going to be 180 minus our first value for B. So that's going to be 118.96. And that step is actually just given to you on your flowchart. So if you noticed, there's a box here on the flowchart which details how to figure out H, how to relate angle A and side A, and how to get your second value for angle B. So it's all kind of laid out nicely for you there. All right, so we have figured out both values for angle B. So now we're going to split this into two triangles using those two measurements. So we've got our first triangle, which has that 30 degrees, has the 42, has the 24, and then it has this angle that we calculated down here of 61 degrees. Our second triangle has the same setup, but now the 24 side is going to be pointing back this way. And so we've got 42, 24, 30 degrees. And this time it's going to be the 119 degrees. So these are sort of the two triangles that we're working with now. So now it really just splits into two separate sine law questions, where we're going to use what we've got to figure out angle C in both of these. So angle C1, angle C2. And then we're going to use that angle to figure out side C1 and side C2. So you don't have to do anything different or strange at this point. There's no weird ambiguous case stuff. You basically just treat this as two separate questions. So our step 3 is going to be to determine, actually I guess we can say that step 3 right there was to split it up. So our step 4 is going to be to determine angle C1 and angle C2. So let's just say angle C for both triangles. So for the triangle on the left, remember to get a third angle in a triangle when you already know two of them, you just do 180 minus the two angles that you know. So we know 30 and we know 61. So if we do 180 minus 30 minus 61, that will tell me that my third angle in this triangle is going to be 80. Well, it'd be 89, but again, we're trying not to round. So 88.96 if you go back and use the unrounded version. And even this is rounded. So remember what I said about not rounding until you have to? This is where storing numbers in your calculator is going to be really important because you have a bunch of different numbers you're working with here. So if you can store these and bring them back later, you can avoid rounding as long as possible. All right, so that's our first value for angle C1. Then we're going to do the exact same thing for the second triangle. Just instead of the 30 or the 61, we're going to be using the 119. So 180 minus the two angles that we know in this triangle. And so you do that, and you're going to get about 31.04. Again, try not to round it till the end. And then our final step is to determine side C for both triangles. So now this is just a sine law thing. So in this triangle on the left, I know that this angle up here, which I don't really have a ton of space for, is that 88.96. I'm just going to say 89 that we found. For this one over here, I know this angle that we just found is about 31. And so if you want to find side C1, you've got everything you need at this point. So you're just going to do some sine law. So sine of that 88.96 divided by side of C1 equals, and try to go back to the pair that you knew right from the beginning, which was the sine 30 and the 24. We do some cross multiplication. We end up with C1 times sine of 30 equals 24 times sine of 88.96. We divide both sides by sine of 30. And we get side C1 is 24 sine 88.96 divided by sine of 30. And so when you plug that into your calculator, if you haven't rounded anything the entire time, even including this, even if you had the full unrounded version of that and anything else, you'll end up with this is 47.99 centimeters. Then you go through and you do the exact same thing for the other triangle. So now it's going to be sine of 31.04, right? So that was the angle that we calculated for C2 over side C2. And then that's still going to be sine 30 over 24. Right, so that was given to us in the question. We do our cross multiplication and all that. We get C2 sine of 30 equals 24 over sine of 31.04. We divide both sides by sine of 30. So it's the same steps that we just did. So you notice there's a lot of repetition here. You're doing the exact same thing just with different angles. So C2 is 24 sine of 31.04 over sine of 30, which tells us our side length of C2 is 24.75 centimeters. And so there's our answer to the question. Side C1 is 47.99. Side C2 is 24.75. It's a lot of work. So there you go. That's how you get two solutions with the sine law. So that's how you get two solutions for your angle, two solutions for your other angle, and two solutions for the side that you didn't already know. I just want to clear up the last couple of things before I wrap this video up. So first up, if a question ever tells you to solve a triangle, that just means find all sides and angles. So that's what we just did, right? So this question that we just finished, we solved that triangle. We solved it twice, right? So we found all the sides and all the angles for both versions of the triangle. So if you ever see solve, that just means find everything you can. Second, just want to talk about this real quick. How many solutions does this triangle have? Oops, not how much, how many? So how many solutions? So if A is 30 degrees, side A is, I don't know, 280 meters, and angle B is 50 degrees. So if you look at this carefully, this actually doesn't seem to match up with your flowchart, right? So we don't have enough info to, say, calculate everything we need, right? We can't calculate H because we have two angles in one side and something seems wrong here. And that's because this isn't ambiguous, right? This doesn't even use the flowchart because this is a case where we have two angles and one side. And so that is automatically, no matter what, one solution. So it's just something to keep in mind when you're doing these kinds of questions. If you see two angles, you don't even touch the flowchart. You just say, okay, this has two solutions, or say one solution, and you go and find that solution and you carry on. All right, so there's one more video left for this chapter. It's going to be 2.4, which covers the cosine law, which is going to look a little uglier than the sine law, but you'll find out is much nicer because it doesn't have any ambiguity. So once you're ready, go look out for that, and then you'll be able to wrap up this chapter.